Question number 1. The numbers 2, 3, 5 and y have an average equal to 4. What is the number represented by the letter y? Okay, so for this one, we know that to find an average, we have to take the sum of all the observations over total number of the observations. Okay, so from the given information, the sum of the observation is going to be 2 plus 3 plus 5 plus y, of which after summing the values here, we are getting 10 plus y. Okay, also we can see from here, the number observation is, we can count them as this one, 1, 2, 3, and 4. So they are 4. And also we've been told that the average equals to 4. Okay, so now let us substitute these values into our formula. We are going to have 10 plus y over 4 equals to 4. Okay, so next let us multiply for both sides. Then we are having 10 plus y equals to 4 times 4. Okay, so solving this, we are having y equals to 16 minus 10, of which this becomes 6. And this is the value of y required. Question number 2. Which numbers are equal to their squares? Okay, so for this one, we know number 0 and number 1 are equal to their squares. And that is going to be our answer. Question number 3. Simplify the expression in brackets 5 over 3 power 3. Okay, so for this one, first let us expand the given expression. Then we are having 5 times 5 times 5 over 3 times 3 times 3. After calculating the value, this becomes 125 over 27. And this is going to be our answer. Question number 4. The difference in the measure of two supplementary angles is 102 degrees. Find the two angles. Okay, so for this one, we know that supplementary angles are two angles forming 180 degrees. Okay, so let us assume y to be the first angle. Then our second angle is going to be y minus 102. Okay, so next we are going to take this first angle plus the second angle must equal 180 degrees. So we are having y plus y minus 102 equals to 180. Okay, so now let us combine the constant terms. We are having 2y equals to 180 plus 102. Solving this, we are having 2y equals to 282. Okay, so now let us divide by 2 both sides. Then we are going to have y equals to 282 over 2, of which solving this, we are having 141. So this is the value of our first angle. Now to find the second angle, we are going to take 141 minus 102, of which this becomes 39 degrees. And those are the values of the two angles requested. Question number 5. In the year 2012, the population of the world was 6.760 billion. write this population number in a scientific notation. Okay, so to write this in a scientific notation, we are going to introduce the decimal point at a 9th position from the first place value. Then our answer is going to be 6.76 times 10 power 9. Question number 6. If n is a number such that when multiplied by 0.75 gives 1, find the value of n. Okay, so from the given information, we are going to multiply 0.75 by n. So we are having 0.75 times n equals to 1. Okay, so next, let us divide by 0.75 both sides. Then we are having n equals to 1 over 0.75. Okay, so next, to eliminate the decimals, we are going to multiply both the numerator and the denominator by 100. Then we are having n equals to 1 times 100 over 0.75 times 100. Solving this, we are having 100 over 75. Okay, so now let us divide both numerator and denominator by 25 in order to simplify this fraction. Then we are having n equals to 4 over 3. And this is going to be our answer. Question number 7. What percent of 1 hour is 15 minutes? Okay, so for this one, you have to recall that 1 hour equals to 60 minutes. Now, percentage of 15 minutes in 60 minutes is going to be 15 over 60 times 100, of which, solving this, we are getting 25%. And this is going to be our answer. Question number 8. Write the fraction 31 over 8 as a mixed number. Okay, so for this one, we are going to take this 31 divide by 8. The quotient is going to be 3. And 3 times 8, we are going to get 24. Then we can see that the remainder is 7. Now, our mixed fraction is going to be 7 over 8. And this is going to be our answer. Question number 9. What is x if x plus 2y equals to 16 and y equals to 3? So we have been given x plus 2y equals to 16 and the value of y equals to 3. So let us substitute this value into our equation. We are going to have x plus 2 times 3 equals to 16. Okay, so solving this and collecting the constant terms, we are having x equals to 16 minus 6, of which this becomes 10. And this is the value of x required. Question number 10. If x squared minus y squared equals to 10 and x plus y equals to 2, find the value of x minus y. Okay, so for here we have x squared minus y squared equals to 10. Let us call this as equation number 1. And also we have x plus y equals to 2. We are going to call this as equation number 2. Okay, so next we are going to use the two square concepts to factorize equation number 1. So we are having in brackets x plus y times in brackets x minus y equals to 10. we are going to call this as equation number 3. Okay, so next we are going to take equation number 3, divide by equation number 2. So we are having in brackets x plus y, in brackets x minus y over x plus y equals to 10 over 2. Okay, so from our equation, we can see that this x plus y is common. Then we can cancel it. And this part 10 over 2 equals to 5. So our equation is going to be x minus y equals to 5. And that is going to be our answer. Question number 11. Rationalize the denominator of the expression 2 over 3 minus under root 5. Okay, so for this one, we are going to start by multiplying this one 3 plus under root 5 both on numerator and denominator. Then we are having 2 times in brackets 3 plus under root 5 over in brackets 3 minus under root 5 in brackets 3 plus under root 5. Okay, so next we are going to use the difference of two square concepts to expand the denominator, and for the numerator we are going to open the brackets by multiplying 2 in each term inside the brackets. Then we are having 2 times 3 plus 2 times under root 5 over 3 squared minus under root 5 squared. Okay, so next, simplifying this, we are having 6 plus 2 under root 5 over 9 minus 5. This becomes 6 plus 2 under root 5 over 4. Okay, so next, let us simplifying this by dividing by 2 both on numerator and denominator. Then we are having 3 plus under root 5 over 2. And this is going to be our answer. Question number 12. Simplify the algebraic expression -2 in brackets x minus 3 plus 4 in brackets -2x plus 8. Okay, so for this one, first we are going to start by opening the brackets. Then we are having -2x plus 6 minus 8x plus 32. Okay, so next, let us collect the like terms. We are having -2x minus 8x plus 6 plus 32. Solving this, we are having -10x plus 38. And this is going to be our answer. Question number 13. Write the number. We've been given the number there in words. Okay, so this one is going to be 2,373,695. Question number 14. Write 2 log base 3x plus log base 3 5 as a single logarithmic expression. Okay, so first we are going to apply the exponential rule. Then our expression is going to be log x squared base 3 plus log 5 base 3. Okay, so next we are going to use the product rule. Then we are having log 5x squared base 3. And this is going to be our answer. Question number 15. Convert this expression 4 times 10 power negative 2 into decimal number. Okay, so here we have 4 times 10 power negative 2, which equals to 4 times 1 over 100. Solving this, we are having 4 over 100. Dividing this, we are having 0.04, and this is going to be our answer. Question number 16. If the area of a square tomato garden is 361 meters squared, find its perimeter. Okay, so for this one, first we are going to find the length. We have to recall the formula to find an area of a square, which equals to length squared. Okay, so let us substitute the given value. Our equation is going to be L squared equals to 361. Okay, so next we are going to apply the root both sides. Then our equation is going to be L equals to under root 361. Solving this, we are having L equals to 19. So this is the length of a square. Okay, so next, to find the perimeter, let us recall the formula which says perimeter equals to 4 times L. Okay, so now let us substitute the value of length we have. Then perimeter equals to 4 times 19. Of which, after solving the values, we are having 76 centimeters. And this is going to be our answer. Question number 17. What is the denominator when 5 over 6 is multiplied by 7 over 8? Okay, so for this one, let us simply multiply the two values. So we are having 5 over 6 times 7 over 8. Solving this, we are having 35 over 48. Okay, so now from this fraction, the denominator is going to be 48. And this is going to be our answer. Question number 18. Without using mathematical tables, simplify the expression under root 9 sine in brackets 162 degrees minus 72 degrees. Okay, so first we are going to solve the values inside the brackets. Then our expression is going to be under root 9 sine 90 degrees. Okay, so we know that sine 90 degrees equals to 1. Then our expression is going to be under root 9 times 1, which becomes under root 9. Solving this, we are having 3. And this is going to be our answer. Question number 19. Find the least common multiple of 24, 36, and 48. Okay, so for this one, let us prepare a table, and then we are going to list our numbers. So we have been given 24, 36, and 48. Okay, so next we are going to ask ourselves what is the lowest number which can divide either of these numbers. So our number is 2, so we have 2 here. We say 24 divided by 2 is 12, and here is 18, and here is 24. Okay, so next we are going to still use number 2 to divide these numbers. So here the value is going to be 6, and here is going to be 9, and here is going to be 12. Okay, so we can still use number 2. So dividing here, we are getting 3. And here, we cannot divide this one by 2. So we leave 9 as it is. And here, the value is going to be 6. Okay, so next, we are going to still use number 2. So here, the value is going to be 3 because it is not divisible. And this one is going to still remain as 9. And the value here is going to be 3. Okay, so our next number is going to be 3. Dividing here, we are having 1. Here is 3. And here is 1. And then next, we are going to have number 3 here. The value here is 1. And dividing here, we get 1. And here is 1. Okay, so next, to find the least common multiple, we are going to take these numbers and find the product of all these factors. So, our LCM is going to equal 2 times 2 times 2 times 2 times 3 times 3, of which after solving the values, we are getting 144. And this is going to be our answer. Question number 20. In a class of 75 from 2 students, 50 like physics, 10 likes physics and chemistry. Apply the general formula to find the number of students who like chemistry. Okay, so this is the set problem. Okay, so let us recall the formula, which says number of A plus number of B minus number of A intersection B equals to number of A union B. Okay, so for this one, we are going to assume number of A equals to those who like physics, which have been given as 50 students. Number of B are those who like chemistry, which we don't know, so we are going to call this as Y. Number of A intersection B we have been given as 10 students, and number of A union B equals to 75 students. Okay, so next, let us substitute these values into our formula. Then our equation is going to be 50 plus Y minus 10 equals to 75. Okay, so next, let us collect the constant terms. Then our equation is going to be Y equals to 75 plus 10 minus 50, of which after solving the values, we are having 35. So this is the number of students who like chemistry. Question number 21. In a bag containing small balls, 1/4 are green, 1/8 are blue, 1/12 are yellow, and the remaining 26 are white. How many balls are blue? Okay, so for this one, first let us find the sum of all the fractions given. So we have for the green, we have 1/4, blue, we have 1/8, and for yellow, we have 1/12, of which after summing the values, the total value of all the fractions equals to 11/24. Okay, so next, let us find the remaining fraction. So we are going to take 1 minus this one, 11/24, of which after solving the values, we are getting 13/24. Okay, so next, we are going to assume Y is the total number of balls. Then our equation is going to be 13/24Y equals to 26 as given from our question. Okay, so next, let us multiply by 24/13 both sides in order to make Y as a subject. Then we are having y equals to 26 times 24 over 13. Solving this, we are having y equals to 48. Okay, so now to find the blue balls, we are going to take 1 over 8 times 48, of which after solving the values, we are getting 6 balls, and that is going to be our answer. Question number 22. Find the size of angle X in the figure below. So we've been given the figure there. For this one, first let us find the value of angle B from triangle ABC. We know that the summation of all the angles in a triangle equals to 180 degrees. We can say that A plus B plus C equals to 180 degrees. Okay, so now let us substitute the given values from our figure. Then our equation is going to be 41 plus B plus 94 equals to 180 degrees. Okay, so next let us collect the constant terms. Then our equation is going to be B equals to 180 minus 24 minus 41, of which after solving the values, we are getting 45 degrees. Okay, so next, let us consider this triangle DBE. Then using the same concept above, we say that B plus D plus E equals to 180 degrees. Okay, so again, let us substitute the values. So here we are going to have 45 plus 110 plus x equals to 180. Okay, so next let us collect the constant terms. Our equation is going to be x equals to 180 minus 110 minus 45, of which after solving the values, we are having 25 degrees. And this is going to be our answer. Question number 23. In a right-angled triangle, tan A equals to 3 over 4. Find sin A and cos A. Okay, so for this one, by considering the tangent value given, let us prepare a right-angled triangle. So here we say P, here is Q, and here is R. Here the angle is A. The value here is 3 and here is 4. Okay, so next let us find the line RQ using Pythagoras theorem. The theorem will be RQ squared equals to PQ squared plus RP squared. Okay, so next let us substitute the values given. So we are going to have RQ squared equals to 4 squared plus 3 squared. Solving this, we are having RQ squared equals to 25. Okay, so next, let us apply the root. We are having RQ equals to under root 25, of which after solving the values, we are getting 5. Okay, so we have to remember that sin A equals to opposite side, in our case is RP, over hypotenuse side, in our case is RQ. Okay, so let us substitute these values. Then we are going to have sin A equals to 3 over 5. And also we know that cos A equals to adjacent side, in our case is PQ, over hypotenuse side, in our case is RQ. Substituting this, we are having cos A equals to 4 over 5. And these are going to be our answers. Question number 24. Draw a Venn diagram to represent the relationship between the sets A, which equals to 1, 2, 5, 6, 7, 9, 10, and B, having elements of 1, 3, 4, 5, 6, 8, and 10. Okay, so from the given sets, let us find the numbers that repeat themselves in both sets. Then we say A intersection B equals to, in brackets, 1, 5, 6, and 10. Okay, so next, let us draw our Venn diagram as required. So we have a table. We are going to have two sets inside our table. And then this is a set for A, and here is for B. And this is our universal set. Okay, so next, let us fill the elements for each set. We are going to start with the values in intersection. So here we have 1, 5, 6, and 10. So next, we are going to fill the remaining values from each set. So for A, we are going to have, here is 2, 7, and 9. And for B, it's going to be 3, 4, and 8. And this is the Venn diagram required. Question number 25. The following pie chart shows a survey of the number of cars, buses, and motorcycles which pass a particular junction. The survey shows that there were 150 buses which were passing the junction. Okay, so from the given information, determine for Roman 1 the fraction of motorcycles. Okay, so we have to recall that a cycle has a total of 360 degrees. Okay, so from the given information, the fraction of this is going to be 210 over 360. Simplifying this, we are having 7 over 12. And this is going to be our answer. For Roman 2, we are supposed to determine the percentage of cars which were passing the junction. Okay, so from here, we are going to take the given values. So here we have 120 over 360. Now to find the percentage, we have to multiply with 100. Okay, so after solving the values, we are getting 33 and 1 over 3%. And that is going to be our answer. For Roman 3, we are supposed to determine the total number of the vehicles, which includes motorcycles, cars, and buses. Okay, so for this one, first we are going to assume Y to be the total number of vehicles. Then we have number of buses equals to 150. Degree of the buses equals to 30 degrees. Okay, so now we have to recall this. Degree for buses over sum of the degree in a cycle times total number of vehicles equals to number of buses. Okay, so now let us substitute the values we have. Our equation is going to be 30 over 360 times y equals to 150 150. Okay, so next, let us make y as a subject. Then our equation is going to be y equals to 150 times 360 over 30. Solving this, we are having y equals to 1,800. Therefore, this is the total number of vehicles required.